Hi, my name is Imran Aslam. Today you are watching the video to calculate the pressure drop of incompressible fluid in the piping system. When the program starts, all the input fields are filled in with a default value of 1 that can be changed anytime by the user during this program. I have divided all the inputs into different sections for the ease to use. Now let's start with the first input section, which is the fluid. Now let's say 100 GPM is the flow rate of my fluid, and the specific gravity I will take 1, considering water as my fluid. Now the viscosity of the fluid I will take 0.5 at 70 degree Fahrenheit, which can be found from the literature. Next section is the pipe dimensions. The pipe outside diameter can be selected from this drop down list, which shows the diameter between 0.125 inches to 52 inches pipes. For this program I will select 4 inches as the outside diameter of my pipe. Next thing is the pipe schedule. Again, the pipe schedule can be selected from this drop down list. I will select 40 pipe schedule. Now by pressing the get ID button over here, the inside diameter of the pipe is automatically calculated. Now the next thing is the length of the piping system, which is, let's say, 1000 feet. Next thing is the elevation change, which is the net elevation change from a reference point. This value can be either positive or negative depending upon the reference point. I will take positive 65 feet is the net elevation change of my piping system. Next thing is the upstream pressure of the fluid in the pipe, that is the inlet pressure of the pipe, which is, let's say, 50 psig. Now let's select the pipe material. That can be selected from the drop down list. All the available pipe materials are given here in the list. For example, I will select carbon steel as my pipe material. Now the next thing is the relative roughness of the pipe. By default, the program, there are two options are given. One is the known and the other option is unknown. By default, the unknown is selected, which means that as soon as the pipe material is selected, its absolute relative roughness will be shown in this list, in this field over here. However, the user can give a different value of relative roughness by selecting the known option. Just as I have select the known option, the input field becomes empty and I can give a different value here. Just for the demonstration purposes, I will keep the unknown option selected and let the program be pick the default value of relative roughness. Now let's move to the other inputs, which is a line contraction. There could be numerous line contraction in the entire piping system. Now the first thing here is the diameter before contraction in the pipe, which is 4 inches. The diameter after contraction in the pipe is, let's say, 3 inches. Now the angle of the contraction can be selected from this list. Here in this case I will select 30 degree. Now the total number of increments means the total number of line contraction in the entire piping system, which is 10 in this case. Now next thing is the line expansions. Similar as the line contraction, the diameter before the expansion in the pipe is 3 inches. The diameter after expansion is 4 inches. Again, the angle of expansion can be selected from this list, which is 30 degree. Now the total number of expander in the entire piping system are, let's say, 12. Now next thing is the pipe fitting. The first field over here, there are, while clicking on this drop down list, there are several pipe fittings are shown in the list. For example, I will select 90 degree standard elbow as my fitting. Now let's give the size of the fitting, which is size of the 90 degree elbow, which is 4 inches, and the total number of 90 degree elbows in the system are, let's say, 10. Now let's select one more fitting for this demonstration. Again, click on this drop down list and select ball valve as ball valve over here. Now for this ball valve, the angle field is shown over here, from where I can select the inside valve body angle, which is the angle of the inside of the valve body. Here, for example, I will select 15 degree as the inside angle of the valve, of the ball valve. Now let's select the size of the ball valve, which is 4 inches, and the total number of ball valves in the system are 5. Now up to this point I have pretty much completed my entire piping system. Now by pressing only the calculate button, all the required parameters which are required for the pipeline design are shown in the result section over here. I will go through each one of them, namely the velocity head loss is calculated, pipeline losses are calculated, pipe fitting losses are calculated, elevation gain and loss is calculated, and the total pressure drop in the system is also calculated. Total equivalent length of the piping is calculated, velocity of the fluid is calculated, final pressure of the piping of the fluid at the exit of the pipe is also calculated, pressure drop per 100 feet of the pipe is calculated, Reynolds number is calculated, total K value of the system is also calculated, relative roughness of the pipe is also calculated, fanning friction factor is calculated, and additionally Moody friction factor is also calculated for the comparison. Thanks for watching this video. For any comments and queries, please contact Imran Aslam at this email address. Thank you very much. Bye.